everyone. For today's lesson, we are going to learn about our last transformation, which is called dilations. Now, dilations is not a rigid transformation because in a dilation, figures become bigger or they become smaller, depending on what we call a scale factor. Our learning objectives for today is for you to be able to say, I can list the properties of a dilation, calculate the scale factor of a dilation, and use the scale factor to draw a dilation. So these are all of our learning targets for this lesson. So as you guys can see, there are a couple of vocab words. We have dilation and we have scale factor. Before we get started with this lesson, I would like you guys to please make sure you have the following materials. First of all, please make sure that you have already printed and cut out the cutouts for Unit 1, Day 4, Dilations. For the interactive notebook, you're going to need to make sure that you have both of these rectangles cut out. You will also need to have a glue stick or Scotch tape in order to tape it into your notebook. I would recommend strongly that you have colors, highlighters, to emphasize different words, as well as something to write with. If you need to pause the video to make sure that you have all of these materials, feel free to do so, and then go ahead and restart the video. The first thing that we are going to do is we're going to work with our first block, which is called dilations. And if you wouldn't mind pasting this directly into your notebook, that would be very, very helpful. A dilation. A dilation, if we look at the picture that I have up here, notice that these two pictures are basically of the same exact type of triangle, but one is bigger and the other is smaller. But they have essentially the same exact shape. So a dilation creates a figure that is the same shape, but a different size. This is known as a similar shape. And we will have an entire unit just dedicated to similar figures. Later on in the school year. In a dilation, a figure is either reduced or shrank or enlarged, got bigger, with respect to a scale factor. With respect to a fixed point, excuse me. Now remember, fixed point means that that point does not move. That's what fixed means. It is a point that does not move. In our class, we will use the origin of 0, 0 as our fixed point. So based on a certain point, which means that we're not shifting left, right, up, or down, based on that fixed point, the figure is either going to get bigger or it's going to get smaller based on that point, but that point is going to remain the same. A scale factor, K, so we use the letter K to represent the word scale factor. K is used to make an enlargement, which an enlargement means that we are making the graph bigger. So I'm going to say an enlargement is going from small to large. Or a reduction, which means that we're going from large to small. So an enlargement is where you have like a figure that starts off being small and then it's bigger. The shape remains the same, but the size is different. So you're going from small to large. Same thing for a reduction. A reduction means that you're starting off with a large figure and it's turning into a small figure. small to large, large to small. Now, it is a ratio. Scale factor is a ratio of a side length of the image to the corresponding or matching side length of a pre-image. So ratio is another word for fraction or a comparison of two numbers. In our case, it will be represented as a fraction that we are allowed to simplify. So the way that you find scale factor is you're going to find the length of matching sides. So like in this case, this side matches with this side. They're matching each other. Even though they're not the same exact size, they are, in terms of the figure itself, they match each other. And if we're saying that this figure came first and this figure came second, this is going to be your image, and this one's going to be your pre-image. And a ratio of the side length of our image to the corresponding means the word matching. So it matches up to a matching side length of the pre-image. Your scale factor is all about what came second compared to what came first. So it is the length of the image So I have the length of a side length of an image compared to the length, which maybe side length is kind of silly, the length of a side of the pre-image. So it's all about what comes second divided by what comes first. Essentially, if we're talking about a point P, it's P prime divided by P. It's the image over the pre-image. So I think that's what I want to emphasize. It's a length of an image compared to a pre-image. And that represents your scale factor K. Now, let's go ahead and talk about reductions versus enlargements. If we have a reduction, what we are going to see is this. In a reduction, we are going from large to small. A picture of that would look like where I have a large picture or a large triangle that changes into a small triangle. The shape is essentially the same. It's just a lot smaller. You'll see that we are going to be identifying something as the image or the pre-image compared to the image. Your scale factor is going to be 0 is less than K, which is less than 1. So what you're going to see K be is you will likely see a fraction or a decimal. Be careful. Not all fractions and decimals are between 0 and 1, so you have to be very, very careful. So that's a reduction. An enlargement that means you're going from small to large. Looks like this. We are starting off with a small figure, and it becomes larger. The shape remains the same. It's just the the size becomes bigger. So you would start off with your first pre-image being small, and then your image becomes large. And the scale factor for an enlargement are all values of k that are bigger than 1. Now what happens if k equals 1? What does that mean? So far I had in between 0 and 1 for a reduction, and k being larger than 1 for an enlargement. But what about k equals 1? Well, that means that the shape is the same, the figures are the same shape and size. Which means that there is no change in the figures. So that means that you're talking about two figures that are exactly the same in every way, shape, and form. They are essentially congruent to each other. So there is no change, and the size and the shape are going to be the same. That's what it means if k is equal to 1. All right, let's go ahead and move on. We're going to do one quick example, or we're going to talk about the coordinate notation for dilations, and then we're going to talk about our quick example, and then that will be the end of our video lesson. Along with some information that I do need you guys to know. So, the coordinate notation basically your coordinate rule for a dilation at 0, 0. Because dilations can happen at any fixed point, but for our class, we're just going to be focusing on 0, 0. So the coordinate notation for a dilation located at 0, 0 is this. The rule is going to be xy changes into k times x and k times y. So essentially what we're doing here is we are going to multiply the k value, which is our scale factor, to x and to y. Let's go ahead and look at our first example. If you wouldn't mind pasting this kind of on the side, and then that way you can do some work on the other side. That might work out a little bit better. It's up to you and your structure. I'm totally open. So for this example, we want to analyze the ordered pairs and figure out what is the scale factor. So looking at our picture, looking at our ordered pairs, we suddenly need to come up with our scale factor. We need to decide, is this an enlargement or is this a reduction? So what we want to look at is our symbols. We have ABC, and then we have A prime, B prime, C prime. So remember that prime notation means that it came second, and no prime means that it came first. So what came first is a small triangle, and what came second was a big triangle. So because we're going from small to large, this means that we have an enlargement, which means that we would expect that our scale factor is going to be bigger than 1. So how do you find that scale factor? Well, what you're going to need to do is you're going to need to look at your ordered pairs. So you can look at any ordered pair, but I'm going to recommend that you pick one ordered pair. And it can be of any point. Let's say that we look at A. A is located at -2, -2. And A prime is located at -4, -4. So you have to ask yourself, what did you multiply A by to get to -4? Well, it looks like if we had multiplied by 2, we would end up with our answer. So the way to find your scale factor is to take a coordinate, like -4, and divide it by a coordinate of the image, and divide it by a coordinate of the pre-image. And that's going to equal 2. So our scale factor in this case is 2. You can look at any of the ordered pairs. So if we were to look at B, for example, B is located at -1, 2, and B prime is located at -1, 2, 1, 2, 3, 4. So -2, 4. Look at that. If I multiplied -1 times 2, it'll get -2, and 2 times 2 will get me 4. Same thing is true for C. C is located at 2, 1, and it changed to C prime, which is located at 4, 2. And what we see over and over again is that C prime is twice as big as the other point that came before. Therefore, our scale factor is 2. This is what we call analysis. Analysis is where you analyze, you look at your information given to you, and then you make decisions and make draw conclusions based on the information that is given to you. The other thing I want you guys to notice about these triangles is that the triangles are the same shape but different sizes. Same shape, different sizes. All right, so there's some things that I need you guys to know about dilations. The first thing that I need you guys to know about dilations, so I'm going to call this conclusion. What I need you to know about dilations is this. Number 1, the size of the figures will be different. Number 2, the angle measures. In the image will be the same as the angle measures in the pre-image. So what that means is that the size will be the same, or the shape will be the same. So because the angle measures have been preserved or are the same, this is the reason for why our shape is the same. And number 3, all corresponding, which remember that corresponding means matching. All corresponding, which I'm going to write the word matching, because that's what this means. All corresponding angles will be congruent. And all corresponding, which means matching, side lengths will be what we call proportional. And they will be proportional or equal to the scale factor. So I'm going to rewrite that or highlight that information again. All corresponding or matching angles will be congruent. And all corresponding or matching side lengths will be a new word called proportional. That means that every single time that you compare something that came in the second image divided by whatever a side length that came in the first image, they will always equal the scale factor every single time. And that is called being proportional. As we get closer and start talking about similar figures in greater detail, once we get to, I want to say that that is Unit 6, but a later unit, we will be talking about similar figures and really diving into proportionality. Until then, that is the end of today's lesson. If you have any questions about anything, please make sure that you email me. Otherwise, I hope you have a wonderful day.